Click the bell icon to get latest videos from Ekeeda.
Hello friends, so today we are going to learn about the eigenvalues and eigenvectors. Particularly in this video, we are going to focus upon similarity of matrices and their properties, and also about the diagonalizable of matrix. So today we are going to learn about the similarity of matrices. Just like in a triangle, we learned about the congruence of a triangle and similarity of triangles. So in congruent triangles, let us take an example. ABC and triangle PQR. In order to understand what is congruency, that is congruent triangles, we'll focus upon the angles as well as the length of the respective triangles. So in this particular case, when I say triangle ABC is congruent to triangle PQR, I mean angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R, as well as AB, length AB is equal to length PQ, length AC is equal to length PR, and also length PC is equal to length QR. This particular case we say triangle ABC is congruent to triangle PQR. So let us focus upon similarity of matrices. If we take two triangles and if these two triangles are similar, then their lengths need not be equal. They should be in proportion, but the angles of the triangles has to be same. Suppose we have got ABC and we have PQR. In this particular triangle, if angle A is congruent to angle P, that is the measurement is same, angle B is congruent to angle Q, and angle C is congruent to angle R, and most important, their respective sides are in proportion, that is AB divided by PQ is equal to AC divided by PR is equal to BC divided by QR. So this is the difference between the congruency and similarity. Just like this, if we say one matrix is exactly equal and congruent to another matrix, that is the elements of those matrices have to be same. For example, if we have A matrix as 1 0 1 2 0 2 and 3 3 3, and another matrix B as 1 0 1 2 0 2 3 3 3, then we say matrix A is equal to matrix B in all aspects. But in case of similarity, the thing is not so. In the similarity of matrices, matrix A and matrix B, if they are similar, then the particular value or these particular elements could be different, but the value and the properties they follow should be same. For example, let us focus upon the definition of similarity of matrices. If matrix B and matrix A are said to be similar matrices, then A and B, they have to be first square matrices of same order n cross n, that is n rows and n columns are present in it, and there exists one non-singular matrix M, where non-singular means the determinant value of M has to be 0, that is singular matrix, and in non-singular matrix the determinant value of M should not be 0. So M is non-singular, that is determinant value of M should not be 0. this is because M inverse of M matrix should exist. So if B and A satisfy this equation, B is equal to M inverse A into M, then we say A and B, these matrices are similar matrices, for example. And there has to be M matrix such that M and M inverse exist, and M inverse into M, there should be matrix B, and this is how the multiplication takes place and we arrive at similarity of matrices. Also, we are going to focus upon, if matrix A we take, same matrix M we take, and M inverse, which is the inverse matrix of M, and if this product comes out to be diagonal matrix D, diagonal matrix as in D has got only diagonal elements A1, A2 up to AN, and there are 0, 0, 0 up to this and 0, 0, 0. So all other elements are 0 and only diagonal elements are present. Then we say D is diagonal matrix. And if A is obeying the rule M inverse into A into M is equal to diagonal matrix, then we say matrix A is diagonalizable. And this was all about the similarity of matrices. Also, we are going to check whether if A and B are similar, then A square and B square, they are also similar, and A raised to N and B raised to M, they are also similar matrices. Prove that if matrix A and B are similar matrices, then prove A square and B square are also similar matrices. By similarity of matrices, we will write down the definition. If A and B are similar matrices, then B has to be equal to M inverse into A into M, where M is non-singular matrix. That means the mod of M is not equal to 0. Therefore, let us take B square, which is nothing but B into B. We'll put the value of B as M inverse A into M into again M inverse A into M. So we can have, so if we focus on M into M inverse, it is going to be I, because the matrix and its inverse gets multiplied. It's like 5 multiplied by 1 by 5. It's a reciprocal, answer is 1. So M is getting multiplied by its inverse, the answer is I. Similarly, here we have got A into I, which is A square. So M inverse into A square into M, which is B square. Now we can see, just like this, A and B are similar, so it has to obey M inverse into A followed by M. Here we have got A inverse by M inverse, so we have got B square is equal to M inverse into A square into M. So I can say by definition, B square and A square are similar. So this is what we have proved. So in this particular problem, we are going to focus upon prove that if matrix A is diagonable, then A square is also diagonable. So in order to understand what is diagonalizable matrix or diagonable matrix, we'll focus upon the definition of similarity of matrices. So when B and A are said to be similar, then it has to follow M inverse into A into M, where M is non-singular matrix. And if this result M inverse into A into M comes out to be diagonal matrix D, that is D is equal to M inverse A into M, this particular multiplication M inverse into A into M gives birth to any diagonal matrix, then we say matrix A is diagonable. So let us focus upon A square. Therefore, D square can be written as D into D, which is nothing but M inverse into A into M into M inverse into A into M, which is nothing but M inverse A M into M inverse A into M. The multiplication has been taken. Now M into M inverse is nothing but I, which is the identity matrix. Now when A gets multiplied by I, answer is A, and A gets multiplied by A, the answer is A square. So M inverse, and the multiplication of this would be A square into M. Now we have got D square. Now we have got A square, we have got D square. It is also a diagonal matrix. So we have got, when A gets post multiplied by M inverse followed by A and M, we get diagonal matrix. Then A square also, when we multiply by M inverse, then A square and M, we get diagonal matrix. So hence it is proved that when A is diagonable, A square is also diagonable. Thanks for watching this video. Stay tuned with Ekeeda and do subscribe to Ekeeda.